In this video, I'm going to discuss completing the square as a method for solving quadratic equations. So I'm going to work through several examples of varying difficulties, and we'll start with this one pretty simple in the first one. So we have x squared equals 27 minus 6x. And the first step of completing the square, and it's kind of a very procedural thing, we just kind of follow our steps one at a time. Doesn't take any logic or anything, just kind of use your algebra and work through it the way you're supposed to. So the first step says to get all of our variable terms on one side and all our numeric terms on the other side. So I have a variable here and my number on the other side, but I kind of got to get rid of this negative 6x. So I'm going to put him on the other side, and when I do that, he'll be a positive 6x, and I'll put equals 27 on this other side. So I have my variables on my left and my numbers on my right. So for the second step, it says, if there is a coefficient to my quadratic term out here, I need to divide every single term by that coefficient so my x squared can be alone. But in this case, he's kind of already alone, so that's kind of an as-needed thing, so we don't need to do it this time. But in a later example, you can bet we're going to do it. So our third step kind of says we're going to complete the square by adding something to both sides. We're going to add b over 2 squared. Well, what is b? Well, when we have our standard form of ax squared plus bx plus c, b is going to be the coefficient of our linear term. So in this case, our linear term is 6x, so the coefficient is x. So what I'm going to add to both sides is going to be half of 6, which is 3, and then we're going to square it so we get 9. So I'm going to add 9 to both sides. And you may notice right here this x squared plus 6x plus 9 actually can be factored as a perfect square, and that's kind of the idea of this. So this left side here will now factor as a perfect square. And what's it going to be? Well, it's going to be x plus b over 2 quantity squared. And my b over 2 was 6 over 2, so 3. So it'll be x plus 3 quantity squared. And on my right side, I'll just have this 27 plus 9, which is 36. Well, now I have this square, this quantity squared here, and only a single variable. So the goal here is to isolate the variable like it is for all the equations that we solve. So since this quantity is squared, I'll take the square root of both sides. So this perfect square and the square root will cancel. So I'll get x plus 3. And then when we take the square root of this 36, we need to add this plus or minus, because it could be a negative 6 that got squared to give us 36, or it could be a positive 6 that got squared to give us a 36. Nevertheless, it'll be plus or minus, and the square root of 36 is 6, so plus or minus 6. So now this is looking pretty nice. To finish isolating my variable and solving for x, I'm going to subtract 3 from both sides. And it's going to look kind of like this. These 3's on the left cancel. I have x equals, I'm going to put minus 3 and then plus or minus 6, which means I'm going to have two answers here. I'm going to have a negative 3 plus 6 and a negative 3 minus 6 as my two solutions, because I have to have two of them, one with a plus and one with a minus. So it looks like x will equal 3 in this case, or x will equal negative 9 in that case. So for my final answer, I can say x will be negative 9 and 3. And of course, you can plug negative 9 and 3 back up here into the original, and you'll see that both of them will work. So let's kind of just step through that really quickly. So negative 9 squared is 81, and then 27 minus 6 times negative 9. So 27 plus 54, yeah, that's 81. So that one of them works. The other is a 3. So let's plug a 3 in up here. So 3 squared is 9. And 27 minus 6 times 3 is 27 minus 18. Yeah, that's 9 also. So both of the solutions that we just got by completing the square will work. So that's our first example. In this next example for completing the square, I have x squared minus 4x minus 2 equals 0. So we mentioned previously the very first step is to get our variable terms on one side and our number terms on the other side. So I'm just going to quickly add 2 to both sides here, and I'm going to get x squared minus 4x, and then equals 2. So now he's over there on the right side. Notice in the last example I left this space right here because I know I'm going to have to add something to both sides in order to complete this square, so I'm just kind of preparing for that. So I leave a space right there. So notice that my x squared term, his coefficient is 1, so I don't need to divide by anything because he's already by himself. So remember now, in order to complete the square, we're going to add half of b squared to both sides. Well, b, remember, is the coefficient of our linear term, so negative 4. And half of negative 4 is negative 2. And when I square that, I'll get positive 4. So I'm going to have 4 that I'm going to add to both sides. So here, again like the previous example, we notice, hey, this can factor as a perfect square. And in fact, it'll be x minus 2 quantity squared. And on the right side, my 2 plus 4 will be 6. So just like we did earlier, I have this perfect square. So in order to isolate this x, my first step is to get rid of that perfect square. So I'm going to take the square root of both sides, use my square root property of equality. And this square and the square root cancel, and I'm left with x plus 2. And when I do that to my right side, remember I need to add this plus or minus in front of my term. So plus or minus radical 6. Okay, so we can kind of get rid of these parentheses now, since we undid all that business. So I can subtract 2 from both sides in order to isolate my x. So it'll be x equals. And remember last time I kind of put this guy in front, so negative 2 plus or minus the square root of 6. So it depends on kind of who your teacher is and what they really want this to look like, but this is okay. But if they want you to break it up, it'll be x equals negative 2 plus radical 6, and x equals negative 2 minus radical 6. And this would be a better idea of the two answers that you're looking for. One has a plus, one has a minus. But again, radical 6 can't be simplified at all. He just kind of is what he is, and he's going to be an irrational number. So we have the real number here, the negative 2, which is the rational, and we have an irrational part. So we can't really put these together any more than what they are already. So x equals negative 2 plus radical 6, and x equals negative 2 minus radical 6 for the solutions of this quadratic equation. In my third example, I have 4x squared plus 236 equals negative 24x. So our first step, remember, is to get the variable terms on one side and the number terms on the other side. So I'm just going to do a swap of these two. So when the negative 24x comes over, he'll be positive. And when my positive 236 goes over, he'll be negative. So we're going to rewrite this as 4x squared plus 24x equals my negative 236. I notice in this step that my x squared term is not alone. He's got this 4. So I'm going to divide every term by 4. So my quadratic term is all by itself. So x squared plus 6x, we'll leave a space right there. And negative 236 divided by 4 will be negative, what do we think? Negative 59, I think. So we're ripe and set up to complete the square. So to complete the square, we're going to take half the b term and square it. Right? So in our case, the b term is 6. Kind of like the first example was 6, right? So half of 6 is 3, and 3 squared is 9. So I'm going to add 9 to both sides. Well, on our left side, again, we have set up a perfect square, so x plus 3 quantity squared. And over here we have negative 50. Okay, so right now, again, since this business is squared and we want to isolate this x, we kind of have to release him. So we're going to take the square root of both sides. And when we do, we put that plus minus over on the right side. So the square and the square root cancel, so x plus 3 equals plus or minus the square root of negative 50. Oh man, we got lots of stuff going on over here with a plus or minus square root of negative 50. So first of all, we can use our notion of dividing out prime numbers. So divide out 2, because we want to simplify this. So 5 gets 5 and 5 gets 1. So inside this radical, we have plus or minus a negative 2 times 5 times 5. We still have a pair of 5s that we can bring out, so don't let that negative get you down. So what happens is this is plus or minus 5 times the square root of negative 2. Well, if you recall, the square root of a negative right here. We can get rid of the negative by bringing it out and putting an I. So plus or minus 5I radical 2, because this radical negative 2 can be written as the square root of negative 1 times the square root of 2, but the square root of negative 1 is going to be our I, our little imaginary number there. So that's why this I comes out, because the negative comes out just like this negative square root of 1. Okay, so I still have my x plus 3 over here that has just been coming down, coming down, coming down, right? So we're still going to subtract 3 from both sides. And remember kind of what's happened in all these, the negative 3 kind of jumps out front. So negative 3 plus or minus 5I radical 2. So at this point, we like for our complex numbers to be in the form a plus bi. So I'm going to go ahead and split this up. So x equals negative 3 plus 5I radical 2, and x equals negative 3 minus 5I radical 2. So there will be the solution for our third example of completing the square. In our final example of this video for completing the square, we have x squared minus 7x equals negative 47 over 4. So like some previous examples, we don't have to divide by anything here in the front, and also our variables are together and our numbers are together. So kind of step 1 and step 2 already done for us. So I'm going to rewrite this so I can put some space right here so I know what it is that I'm adding to both terms, or both sides rather, and then I have plenty of space. I notice my 7 is an odd number this time, so when I take b over 2 and square that, it's going to be 7 over 2 squared. Okay, so that's not going to come out nice. It'll be a fraction, so plus 49 over 4 on both sides. Well, that's kind of nice because we already have common denominators over there on the right side. So my negative 47 plus 49 is 2 over 4, and then 2 over 4 is just 1/2. That's not so bad. And my left side, remember when I complete the square, it'll be x and then minus b over 2, in this case it's minus, and then squared. So half of our 7 was x minus 7 over 2, quantity squared. Okay, we got some fractions in here, but don't let that get you down. So again, square root of both sides with a plus or minus over here on the right side. So our square and our radical cancel, so x minus 7/2 equals plus or minus the square root of 1/2. Well, let's take a moment and kind of push this over here and look at what this looks like. Kind of take a closer examination, if you will. So the square root of a fraction, remember, is the square root of the numerator over the square root of the denominator. Well, the square root of 1 is 1 over radical 2, but we have to rationalize this denominator, so we're going to multiply the top and bottom by radical 2. So we're going to get radical 2 over 2 whenever we simplify that. So let's come back over. So I have x minus 7/2 equals plus or minus radical 2 over 2. Okay, so I'm going to add 7/2 to both sides, and remember he's going to kind of come up front. So those cancel. So x equals 7/2 plus or minus radical 2 over 2. And kind of like we mentioned before, if you want to split it up, you can. So it'll be 7/2 plus radical 2 over 2. And 7/2 minus radical 2 over 2. So another way to write that. So here we have seen completing the square as a method of solving quadratic equations. It's very procedural in nature. You just kind of follow the 5 or 6 steps, and then you're going to come out with the answer every time.